Midterm is finished. Now we will start studying for the final term. Okay. So start a new one that is called Euler Cauchy equation, and we are still in second order ODE. Okay. So this concept Euler Cauchy equation was proposed by two mathematicians. One is called Leonardo Euler. Another one is Augustin Louis Cauchy. So this guy is a Swiss mathematician. And this guy is a French mathematician. Okay? And this second one is also called as father of model analysis. Okay. So the concept we are going to discuss is actually proposed by these two persons. Okay. So directly I am coming to the concept. So what is this concept? This Euler Cauchy equations are ODEs of the form this one x square y double dash plus ax y dash plus b y is equal to 0, where x has to be greater than 0, a and b are constants and y is unknown. Okay. So this is the ODE. So important point mentioned here. This is the ODE. X has to be greater than 0 and a, b are constant and y is of course the unknown form that I told you. And to address this particular problem, we substitute y is equal to x to the power m. Okay, we substitute y is equal to x to the power m is one of the solution. Okay, just like we did in the OD with constant coefficient e to the power lambda x. In the previous chapter we studied e to the power lambda x, right? So here we substitute x to the power m. Now if I will take y is equal to x to the power m, then my y dash is equal to m x to the power m minus 1, and my y double dash is equal to m into m minus 1 x to the power m minus 2. So simple. So then my job is to put this value, this y value, y dash value, and y double dash value in this particular problem, which is the given OD. I need to put this values. So if I put this value, what will be my, I can rewrite this equation as x square y double dash is m into m minus 1 x to the power m minus 2 plus ax, y dash will be m into x to the power m minus 1 plus b x to the power m is equal to 0. Right? Simplifying this one, I will get m into m minus 1 into x to the power m plus a m x to the power m plus b x to the power m is equal to 0. Everywhere we have x to the power m. So taking that one out, I can rewrite this one as m into m minus 1 plus a m plus b is equal to 0, or I can rewrite this one as m square plus a minus 1 m plus b is equal to 0. So this one, either form, is called my auxiliary equation. There we studied, we found out characteristic equation. Here this one is called auxiliary equation. Right? So if I will name this one is my equation 1, let's say I will put this one is my equation 1, this auxiliary equation is my equation 2. So I mentioned something, if you notice, this equation And in the beginning I mentioned this particular one is one of the solution. That is what we need to find out, right? So here y is equal to x to the power n is a solution of question 1, that is original OD, right? How now when if double F, if and only if M is a root of equation 2. Which one equation 2? This auxiliary equation. We initially consider y is equal to x to the power m, and that one will be a solution if and only if m is a root of this auxiliary equation. Clear? Now the point is finding the root. So if you try to solve this one, it is pretty much similar way in the characteristic equation. If we solve it, we will get two root. One will be m1, that is 1 minus a by 2 plus 1 by 2 1 minus a square minus b by b square root, and m2 is equal to 1 minus a by 2 minus 1 by 2 1 minus a minus b square. Oh, okay, it's getting complicated one. Okay, maybe I can simply write in this form. Yeah, it's pretty simple way. Right? Now we come to the same question as in the previous case. We will encounter three different scenarios. What are those? Real, two real independent solution, one double solution, another one is the imaginary solution, complex number. Right? Okay. So let's address all the cases one by one. Case number 1. Real different roots, that is M1 and M2. In that case, the y1 is x to the power n, and y2 will be, sorry, x to the power m1, x to the power m2. And the solution y is equal to c1 x to the power m1 plus c2 x to the power m2. This is which case? This is the case when 1 minus a square minus b by 4 is greater than 0. Oh, so yeah. This is the case for I am not getting any permanent solution to this issue. The 200. Okay. Don't eat in front of me. If I will see you eating, I will feel hungry. That's fine. You finish it. Okay, that's fine. Okay. So let's take a simple example to address this one. Then we'll go to the second case. Okay. So I'm taking one example. You have to solve it. I'm not going to solve. Example here. The given OD is x square y double dash plus 1.5 x y dash minus 0.5 y is equal to 0. First step is to find out the auxiliary equation. You need to find out what is your A and what is your B. And accordingly you have to find out your auxiliary equation. You have to match it with the given OD and find out what is your A and what is your B. Yeah. Anybody has any solution? Could you tell me? Yeah. What is your A and B? .5 and minus 0.5, right? Yeah, auxiliary equation. What happened? Shift. Come on guys, why are you taking so much time? Tell me the auxiliary equation. Anybody has the auxiliary equation? Yes? You have auxiliary equation?
M square plus 0.5 minus 0.5.
M square plus 0.5 m minus 0.5. Yeah, that's right. Remember the auxiliary equation is a minus 1 into m. M square plus a minus 1 into m plus yes or no? So by that logic, this is your auxiliary equation. And solve it. This quadratic one. How much is your m? M1 and M2. 0.5 and minus 1. Very good. Then your y1 is x to the power 0.5 and y1 is x to the power minus 1. Your solution y is equal to c1 x to the power 0.5 plus c2 x to the power minus 1. That's your solution. Right. Now let's go to the case 2. What is the case 2? A real double root. That means M1 equal to m2 is equal to 1 minus a by 2. This is the case where 1 over 4 1 minus a square minus b is equal to 0. This is the second case. For this, we have to follow the same method as we did in the previous one. Previous one means I am talking about ODE with constant coefficient. If you have one solution, use that one to find out the other one. That means I am talking about for the ODE, if y1 is equal to x to the power m, we can use the method of reduction to find out y2. How? Then y2 is equal to u into y1, or you can say u into x to the power m, where u is what? Is an arbitrary function. U is an arbitrary function, and our job is to find out what is the value of u. Then we are done. So what we need to do? Find out u2, u2 dash, u2 double dash, and put back those values into the problem. That is the step, method of reduction. Let's begin that one. y2 is equal to u x to the power m. y2 dash is equal to u dash x to the power m plus u into m into x to the power m minus 1. And y2 double dash is equal to u double dash x to the power m plus 2u dash, I am writing directly, plus 2u dash m x to the power m minus 1 plus u m into m minus 1 x to the power m minus 2. What is my OD? The problem we have here, x square y double dash plus ax y dash plus by is equal to 0. Now my job is to put these values of y2, y2 dash and y2 double dash to this problem and try to solve it, simplify it. Right? So let's proceed and do it. So first let's put the x square, so that implies this is x square. Now I'll put a big bracket here to put the y2 dash value, that is u double dash x to the power m plus 2 u dash m x to the power m minus 1 plus u m into m minus 1 x to the power m minus 2. This is the first term. Second term will be plus ax u dash x to the power m plus um x to the power m minus 1, the second term. And the third term is b u x to the power m is equal to 0. Right. Now I will open the bracket. So if I will rewrite this one, it is going to be u double dash x to the power m plus 2 plus 2u dash m x to the power m plus 1 plus u m into m minus 1 x to the power m. This is the opening of the first bracket. Then the next one I am writing here, a u dash x to the power m plus 1 plus a u m x to the power m plus b u x to the power m is equal to 0. Pretty much everywhere we have x to the power m, right? If we drop the x to the power m and try to rearrange the terms, we will get something like this, keeping the u double dash together, u dash together, and u double u together. We will get a term something like this, u double dash x square plus u dash 2mx plus ax plus u into m plus 1 plus am plus b is equal to 0. notify me if I am making any mistake. Any mistake? No.
Y is n plus 1.
Yeah, that's the point. Yeah, it should be m minus 1, right? Now, tell me what is this value? Sorry. What is this value? 0. And what about this value? What about this value? What I can do that I can take this x out. Maybe I can write put this x here. Okay. What is this value? So if you notice, this one, I can consider this is equal to m. It's the same thing. So this is nothing but I can say this is 2m plus a is equal to 1. Yes or no? So then I can mention this one is equal to 1. That implies what I left is this one. U double dash x square plus u dash x is equal to 0. So x is quite common, so I can drop 1. So finally I am left with u double dash x plus u dash is equal to 0. Now, what I need to do is this is a second order one, so I have to reduce this one to first order. So let's set u dash is equal to v and u double dash is equal to v dash. That means I can rewrite this equation as v dash x is plus v is equal to 0. Right? So this one is nothing but d by dx of xv is equal to 0. Or vx. That means I can say this xv is, if I take the integration, is equal to some constant c, or I can say v is equal to c by x. Now for simplifying my solution, let's set C is equal to 1, because C is a constant, I can take any value. For simplifying my solution, I am taking C is equal to 1. That means my V is just 1 by x. Right? If V is 1 by x, what is V? What is V? U dash. Because it is all started from U. That means U dash is equal to 1 by x. If U dash is 1 by x, what is U? U is equal to ln x. So we were looking for y2. So we begin y2, right? We started from y2. y2 is equal to u into y1, that is u into x to the power m. Now we have what is u? U is ln x into x to the power m. That is my y2. So that implies I can now say my solution y is equal to C1 plus C2 ln x into x to the power n. Fair enough? Okay. So let's take one example to check this one. Also we have the alternative, that means simply applying the formula to get the y2. We'll discuss that one. So let's first solve this one and check this one using one example. That means whether we are getting it or not. That means some example, let's say. Here is the question for you. X square y double dash minus 5x y dash plus 9y is equal to 0. Yeah. You need to find out the solution to real double root. Just need to apply the formula to get the solution. What is your A, what is your B, what is your auxiliary equation, and what is your solution? Okay. Yeah, can you tell me your auxiliary equation? Minus 6m plus 9 is equal to 0. Your m1 is equal to m2 is equal to 3. And your solution y is equal to c1 plus c2 ln x into x cube. Okay. Okay, so one thing is left is the other method, and another one is the complex number one. Okay, so that one we can discuss in the next class. It's already over, just 1 minute left. Yeah, so have you checked their answer sheet? Have you checked their answer sheet? Exam, midterm. Okay. Try to check this weekend. Okay. Then inform them and fix a time schedule on which time you are available. So they will come and check their grades in the lab. You just give your lab location. Okay, and give them the time. That when you are available, they will come and check their grades. Okay. So make a particular date, this 1-2 hour, they will come and check. Okay. Yeah. So that you will not disturb, this will not need to come anytime. Okay. Thank you very much.